Hello and welcome to the Internet of Water Coalition webinar series. I'm Faith Sternleib, Associate Director for Engagement for the Internet of Water Initiative at Lincoln Institute of Land Policy's Center for Geospatial Solutions. Today we have Kendra Kaiser at Boise State University in Idaho, who will be presenting on the Pacific Northwest Streamflow data catalog. Before we get started, I'd just like to cover a couple of housekeeping items. We are recording the webinar today, so the recording and slides will be available on the Internet of Water YouTube channel about a week after the webinar. So if you'd like to refer back to anything you heard in today's webinar, or if you'd like to share it with friends and colleagues, you'll be able to do so through our YouTube channel. We'll also be taking questions throughout the webinar through Q&A. So if you could please jot down your questions in the Q&A, we will get to them after the presentation. If you have any technical issues, please put those in chat. And we will try to resolve them as soon as possible. So now on to the main event today. I am pleased to welcome Kendra Kaiser, Assistant Research Faculty in the Department of Geosciences from Boise State University in Idaho. Her presentation is on research and the stakeholder engagement process she and her colleagues conducted on the Pacific Northwest Streamflow data landscape. So with that, I'm going to give the floor to Kendra.
Thank you, Faith and the Internet of Water for having me. I am really excited to talk about the research that we've been doing in the Pacific Northwest for the past few years. This project was funded by the Northwest Climate Adaptation Science Center, and it was in collaboration with the USGS, both here in Idaho, as well as the Oklahoma-Texas Water Science Center. So just to start us off, as many folks are probably well aware, global streamflow data are biased. They are biased towards high order streams that are often highly regulated. They're centralized in locations with high population density, in places that have large human imprints, and they also disproportionately favor the mid latitudes. And this work by Krabanoff et al. Highlights places that could be high priority locations for additional streamflow monitoring. And the important thing here is that the data set that went into this project were data that were widely available already. And so, for example, the USGS Streamflow network, which is our largest network in North America, has over 8,000 gauges as of the past year. But these gauging location biases are similar to that global bias. And the thing that's also pretty interesting is that the number of gauges that are running on any given year are pretty variable. And this is due to the different costs and objectives of individual gauging locations, and that the fact that the USGS actually collaborates with other organizations to operate their streamflow networks. And so in this figure, we see year on the x-axis and the number of gauges on the y-axis, and the black line is showing that nationwide USGS network. And then in the blue line, you see the network in the Pacific Northwest. So here, the Pacific Northwest is Idaho, Oregon, and Washington. And you can see that in the Northwest, it is not quite as variable over time, and it stayed pretty consistent across the past 20 years or so. But the thing is that we know there is additional data out there, and that we need additional data because resource managers require observational data for all sorts of efforts like culvert sizing, permits in national forest land, ecosystem protection, restoration. And then on the science side of things, we need additional data to improve calibration and validation of predictive models to answer all sorts of hydrologic questions. And by having diverse organizations collect streamflow data, it does provide some resilience against that various funding mechanisms, equipment failure, or protective gain or potential gains from having lots of different data in many places. And so some of the data that are out there, we know that they can be held within various data archives that are available online. For example, the Research Data Archive from the USDA. There are state repos that are available, or there are researchers out there like myself who are collecting data. And the community is working towards making Streamflow data fair or findable, accessible, interoperable, and reusable through efforts such as those that are done by the Internet of Water. But the challenge is that this data still exists in lots of different repositories. And so the objectives of this project were to catalog any non-USGS Streamflow monitoring locations in the Pacific Northwest, both continuous monitoring locations and miscellaneous or discrete measurements, or for example, places where you might go take one measurement in a given year rather than having those continuous gauges. Another objective was to engage with individuals and organizations that collect Streamflow data across the region to identify some of the challenges that they have with conducting Streamflow monitoring and implementing those fair data practices. And then the third objective was to develop a data visualization of these non-USGS Streamflow gauging stations with our stakeholders to be able to help identify where additional data is that they might use in their efforts. So the process of this project first started with having input from a stakeholder advisory board. So this board was made up of folks from federal, state, local, city, nonprofit organizations across the region. And with them, we got their input on a water data survey that I'll talk a little bit more about. But basically, we were trying to assess information about different organizations' Streamflow monitoring networks. So as a whole, what's the goal of their network, about how many gauges they operate, and things like that. We also worked with them to develop a template of the most important metadata for any given monitoring location. And so this metadata template goes into a lot of detail, some of which we didn't actually obtain from folks. So I'll talk about that a little bit more. And then we distributed this metadata template and the overarching goals of the project to a huge list of stakeholders in the region that were also co-developed with this advisory board. And so that was kind of our initiation of the project. We really wanted to get the word out there to different folks that we were working on this so that we could start engaging folks. And so from there, we sent out that, we started to get information back from that water data survey. We engaged with data providers to obtain and modify their metadata based on where their data was at in the first place. And we compiled that metadata. This was a huge effort by many students at Boise State, and they did a really phenomenal job of keeping track of all of the different data sources and doing quality assurance, quality control on things like the location of the stream gauge or additional details about any given monitoring location. And then we also derived additional geospatial information to streamline some of the process. So for example, that additional information would be the HUC that any given location was located in, or county, or any other information that was easily obtained from geospatial data rather than having to manually enter that information in. And then from there, we created the initial Streamflow data catalog visualization. And then we held state roundtable discussions that were largely modeled after some of the initial roundtable discussions that the Internet of Water had done in New Mexico and Texas and California. And initially we had planned on having a big roundtable discussion for the whole region, but this was all happening amidst 2020 and COVID-19. And so we actually ended up having an individual roundtable discussion in each state, and then had a online conversation after the fact, kind of discuss the through lines from the individual discussions. And we also used that time to get feedback from the stakeholders about the data visualization, how they would like to see it improved. And so with that, I'll just show you the busiest slide I have today, showing all of the different folks that were engaged at different points in time through this project. So there are folks on this slide that were engaged in every single advisory board meeting. There were folks that came to the state roundtable discussions, folks that provided data to the catalog. And as you can see, this is a huge slew of diverse organizations. And without all of their input and effort, this project would not have been possible. So a huge thank you to everyone that engaged throughout the effort. So what did we find? The first thing that I will tell you all is that there is a lot of data out there. So streamflow monitoring in the Pacific Northwest is pretty impressive. We have over 2,600 continuous gauges in our Streamflow data catalog with over 30,000 discrete measurement locations. In Idaho, Oregon, there are, over 12,000 locations between both discrete and continuous, and then over 6,000 in Washington. And some additional detail on these that you can see from this figure is that of those continuous gauges, we have about 540 that are active, so they're currently running, 819 that are inactive, so they had been operating at some point in time but are no longer, and then about 1,200 locations that are unknown. And this unknown is really important for us to think about, because the reason why it's unknown if it's active or inactive is because there's incomplete metadata. And so this inconsistency in which metadata is captured by these different organizations is really important for us to focus on and think about how we can facilitate improved metadata standards in the future. Some additional data information about the data that's out there. Across the region, the duration of record is pretty phenomenal. In some locations, over 100-year-long data records. The largest proportion of them are data records that have that are in the past 5 to 10 years, but certainly there are plenty that are over 20 or over 60 years old. So it's really exciting to see these really long duration of record, because that can give us some of the most valuable data that we can rely on for some of these modeling and management efforts. So then I'm going to switch gears into some of the results from the survey. And so the survey captured at least 30 organizations, likely closer to 50. We learned quite a few things from the survey and distributing it to folks, but some of the things that are highlighted here are the purposes of the different networks. And so we split up the networks by the size. And so there were 29 networks that had less than 10 gauges, about 11 networks that had 11 to 40 Streamflow gauges, and then 9 networks that had over 40 gauges in their network. And the thing that was really interesting is that these really large networks are largely some of our federal scale networks. And the primary purpose of their monitoring networks are to fulfill statutory requirements. And then when you go into these mid and small scale networks, their primary purposes are for habitat or ecological monitoring and restoration activities, which is really interesting to think about. The size of these networks is related to the primary purpose. And so how they're managing their data and the information they have about them is going to be aligned with both the purpose, funding streams, and things like that. And here it's also really interesting to note that while there are a lot of networks that have really small number of gauges within their network, when you start to compile all of them into the size of a region like the Pacific Northwest, the number of gauges that they are maintaining actually becomes quite important. So the other thing that we were really interested in from this survey was understanding what kind of quality assurance and quality control folks are using to manage their data. And this is of particular interest to the USGS, who we can all say has the highest quality assurance, quality control standards. And so one of the things that was really interesting is that there are a handful of organizations that have no review of their data. There are quite a few, close to half, that review their data when they download the data from their monitoring location. And then there are about a third that actually do have a peer review. And so peer review is where you've downloaded the data and then you have somebody else check it to see if there's anything strange or erroneous about it. And then a pretty small fraction, about 15% of organizations, that actually audit their data for long-term consistency. So this is really important when we think about sensor drift, or if there are any changes in the channel that might create poor relationships between rating curves and actual stream flow. And these 4 steps are kind of the steps that the USGS uses to rank their data themselves. And so this blue slice of the pie is what we would consider the most high quality out of the data out there. And then the other thing that was interesting that kind of aligns with the previous slide is that a lot of these smaller organizations are primarily collecting their data for their own organization's needs, and then perhaps by their local or community needs. But the national scale activities are not really important for their collection purposes, which really speaks to if and how there is impetus for folks to make sure that their data is available beyond, say, their state boundary. So some additional national context for where Streamflow data is. So this figure is from Rui et al. It's a Nature Sustainability paper from 2018. And it's showing HUC 6 basins that are at risk for declining stream gauges based on both water scarcity or flood risk. And so the basins that have hash marks in them are basins that are at risk for a declining number of stream gauges. And if they are red, then they are in a zone of water scarcity. If they are blue, they're at risk for flooding. If it's black, then they're at risk for both. And you can see that it's really highly variable across the country, but certainly in the Pacific Northwest, there are plenty of large HUC 6s that are at risk for declining streamflow gauges. And you can see when we look again at the USGS nationwide data set, there has been a lot of fluctuation through time, and there's some really cool visualizations from the USGS on the history of their streamflow gauging network. And then when we add on our Pacific Northwest, there's not quite as much variability in the USGS network, but when you add in the information from our Streamflow data catalog, let me see if it'll come up. You can see that in the past 20 years, the data that's being collected outside of the USGS almost equals the number of continuous monitoring locations by the USGS. So this really fills out a lot of those potential areas where you might need additional data if it were to be centralized in one location. And when folks are doing the analyses like Rui et al. Or that global gauge analysis, or the global gauge bias analysis, they are not able to capture all of these additional streamflow monitoring locations. So now that we have an idea of about how many additional gauges we collected in this effort, I'm going to jump into a little bit about the data visualization that we created. So here is a figure from our Streamflow data catalog visualization, and I think they're adding some links into the chat so that you can check it out yourself. I will give the caveat, it's pretty slow. This was developed through Tableau, which is what the USGS has been using for these kind of efforts. And first, we are seeing here all of the USGS streamflow gauges in the Pacific Northwest, and each of the circles is scaled by the number of monitored years. And then in the data visualization, there are a handful of filters over on the right-hand side. So things like the organization, state or county, the name of a watershed, whether or not they're measuring stage versus discharge, and all sorts of other details. And so here, these USGS gauges that are being shown are all continuous gauges. In the Streamflow monitoring, or in the Streamflow data catalog, we not only collected those continuous ones, like I said, but also discrete measurements. So when we add on the continuous monitoring locations, you can see how many additional locations pop up. And in some watersheds that didn't have any monitoring, all of a sudden you have a lot of observations. And so here, some of our biggest data providers are the states. So in blue is the Oregon Water Resources Department. In the teal blue is the Washington Department of Ecology. And then over in Idaho, we have the Idaho Department of Water Resources. And some of our really long-term monitoring networks, if you look over in the southeast corner of Idaho, is actually from PacifiCorp. So they are monitoring networks from our large dam operators. And then when you go a step further and you add in all of our discrete measurements, all of a sudden we have a huge, really dense network of Streamflow data. And so it's really compelling to see how much additional information that we can get when we actually put it all in the same place. So some additional data exploration that we added into the data visualization after talking with our stakeholders was the ability to zoom into a given watershed and kind of get a little bit more detail about the data within this watershed. So here we are looking at the Walla Walla Basin, and you can see that there are about 6 or 7 different organizations collecting data in this basin. And importantly here, the Walla Walla Basin covers both Oregon and Washington. And so you have multiple different state agencies as well as the Forest Service. And in this data exploration tab, you can, when you select by a watershed, then you can get all of the sites in there, and then it will provide you some general information about the data interval, for example, or if the data is being collected as flow or stage height, frequency of the data being collected, and then in some cases, the stream type. And you can see when you're looking across here again that there are a lot of these that say unknown. And this is a big issue for us because the data that we integrate is only as good as the metadata that it is brought in with. And so in this case, there are plenty in the Walla Walla Basin. There is data sets that we brought in where we didn't actually have information about the interval at which the monitoring is actually occurring or the units associated with it. And so this comes back to that point that I mentioned where we had this really dense set of metadata that we were hoping to get from all of these organizations, but very rarely did we actually collect anything more than the lat long, the start and end date, and the name of the site. If we could get those 3 things and we were able to put them in the catalog, but the additional information that we were looking for, like which sensors were being used or the data interval, how often the rating curves are updated, the accuracy of their GPS location, a lot of that information was rarely available for many of these organizations. So another tab that we have for the data exploration is looking at monitoring timeframes. And this was something that was brought to us by our stakeholders because oftentimes you want to know not just if there is data, but how long the data has been collected and how consistent it is across these different organizations. And so we have these monitoring timeframes tab where you can see the duration of record, and then we have it characterized by whether or not it's publicly available or not. And most of the data sets that we have in here are publicly available online, but there are a handful that they might be publicly available, but you would have to contact the individual to get the data from themselves. And that was part of a really big time component for us, was contacting all of these individual organizations to get their data that wasn't already online. So from there, I'm going to circle back around to our roundtable discussions. And they were probably some of the most interesting components of this project for me, largely because there is a lot of consistencies, even though we had 3 separate roundtable discussions. So number 1 is that volatile funding sources are really challenging for small organizations. So these could be watershed councils. That we did talk to a few tribes, not as many as we would have liked, which is going to be some future work. But if organizations are having to seek 3 years of funding at a time for an individual monitoring location, then it becomes really hard for them to maintain those into the long term. Additionally, there are very few organizations that are able to match the USGS data quality standards. So that came out in our survey that we sent out to folks. And then in talking to folks during the roundtable discussions, some of the challenges were that they didn't have the ability to get do some of the USGS training that's currently available. So a lot of that training is behind a paywall. You have to be within the USGS organization to access it. Some folks had found some YouTube videos that had been developed back in the day, but when you have a small organization that maybe only has 3 to 5 employees, or a city government that has a watershed division with 5 or so employees, it's not feasible for them to sift through a 200-page standard operating procedure that's available online from the USGS. And so being able to identify ways to make these SOPs or metadata standards more easily accessible to organizations, particularly the small organizations, would really improve their ability to be able to improve their data quality. And then the other component is that that is probably not surprising to anyone on this call, but not all organizations have an actual accessible Streamflow database. And so some of the things that we heard from organizations, particularly these smaller ones, is that they might have a proprietary database like Whiskey or Aquarius, but it becomes really challenging for them to maintain those kind of databases that are really expensive. And so perhaps they might just have, they might be hosting all of their data locally via Excel or some other code base that they've developed themselves. And then actually making that accessible outside of their organization is really outside of the scope of what they have the capacity to do. And so part of this conversation also led us into what are some of the solutions to these challenges. And so the first thing that we could really start thinking about are what are some fiscal or like funding mechanisms to help people actually manage their data. And so they may be able to get resources to implement new monitoring, but there should be a structure under which they can actually get funding to help with their data management itself. And like I mentioned previously, we should really, as a community, prioritize simplifying and centralizing operating procedures and metadata standards in ways that are actually accessible to even small organizations. If we can help the smallest organization, then every organization will be able to use these kind of materials. And then the other one that was a really common one is thinking through how we can create automated and open source quality assurance and quality control workflows. So for example, folks said, it would be so nice if I could upload my data online somewhere and then it automatically flag data that is problematic. There's examples of this in the community already. There's a big group that is studying stream metabolism across the country from Duke, and they have created Stream Metabolizer package where folks can upload their data to the Stream Metabolizer group, and then it is automatically flagged and cleaned, and then the user can then use their data for whatever research purpose that they need. And so methods like these are out there, and the question is how can we actually implement them and make them easily accessible to folks? And then on top of that, we have the Internet of Water that is doing lots of really cool things. And so their GeoConnect system is a way to register individual monitoring locations that creates a unique identifier for any individual monitoring location and links to a URL. This is really valuable for organizations that have their data online. But again, many of these small organizations don't have their data online yet. And so thinking through what are ways that we can help them get their data online so that they can be findable through things like GeoConnects. And then in conjunction with the USGS Water Mission Area, who has been creating this network linked data index. So this helps folks link an individual monitoring location to the national hydrography data set. And so making sure that all of these different structures are linked to each other are things that are getting moved forward at a national level, which is really exciting. And so it's kind of both a top-down and a bottom-up efforts that are really needed. So then the last thing that we did through our the report that came out of the 3 different roundtable meetings was a SWOT analysis. So it's the strengths, weaknesses, opportunities, and threats. And basically what it's trying to say is like, where are big challenges, both internally and externally, and then and where some value adds. And so we created this around the Pacific Northwest data landscape effort. And so some of the strengths is that we created a lot of community around Streamflow data in the Pacific Northwest. There are a lot more people that are talking to each other now that have different ideas that they can share. We developed, one of the strengths is that we did develop this initial Streamflow data catalog, and we identified some common challenges and needs. Some weaknesses about it is that all of the individuals that I mentioned being involved volunteered their time. So this is not a funded priority for any of these other organizations to put their time into it. And then the other thing is that any existing work to modernize data infrastructure across these organizations are really piecemeal by either individual states or organizations. So there's really limited coordination around things like metadata standards. In the bigger picture, some big opportunities are that the fact that the water mission area is exploring tiered gauging. So this concept of tiered gauging is that the USGS gauges are our tier 1 gauges. And then perhaps another organization that is not able to meet all of those quality assurance checks are maybe tier 2 or tier 3. And so if we can identify what different tiers of Streamflow data are, then it will improve our ability to integrate across data sets. And there are examples through the USGS of funded training opportunities, for example, with tribes. But some of the big opportunities there is like, how can we expand these training opportunities to be available to lots of different organizations outside of the USGS? And then obviously, as we are all here on an Internet of Water webinar, the Internet of Water is really facilitating a lot of these community engagement opportunities. Some of the big picture challenges on the external side of things is that there's no one funded organization or long-term program around that. And so it creates a gap in funding for coordination across partners. So it's largely a community-driven effort where we want to be engaged together, but there is no funded mechanism to do so. And then overall, there's also a general lack of attention to small organizations who generally need the most support. So oftentimes when we're initializing some of these efforts, we want to go for the biggest bang for the buck. So who has the most data out there? Oftentimes those are state agencies. While that is really valuable, those agencies already have a mandate to collect data and centralize it. While, all of these other small organizations really need a lot of support. And if we are able to create that support, then we can integrate a really diverse set of data across large spatial areas. And then a couple of thoughts on the USGS side. This slide came from a presentation to the water mission area, is just pushing the USGS to continue to advance their tiered gauging concept. So actually performing the science and writing the description behind different methods that would fall into different tiers. And then having the USGS help advance fair data practices for the benefit of all organizations. So some final take homes here is that there is a ton of data out there. We all know this. If you're joining this call, you're aware of data in your own organization. But we also know that integrating this data is a really big task. And so the very first thing that we can do is find out where the data are located, both within an individual organization and then also across space. But in order to really compile things, metadata needs to be complete. We need to have sufficient description of data to understand the quality, duration, and methods associated with them. But to do this, we need to allocate resources to organizations to actually facilitate their data management. And then on top of it, when we create things like the Streamflow data catalog, it really increases the visibility and utility of ongoing Streamflow data collection. So it lifts everyone up when we can say, in our watershed, there are 10 different organizations that are collecting data, and each of them are really contributing to this bigger overall picture of the hydrology of a given system. And so with that, I will leave this link up and a quick poll. If you have Streamflow data that you think other people want to know about, you can fill out this survey. It's a quick couple lines. If you want to talk about this more after the presentation, you can always send me an email or ping me on Twitter. And then we have a couple of papers out about this. The one that I'm showing on the screen now is a summary of all of the data in the Streamflow data catalog. And there we also have the manuscript on the survey that is about to be submitted for its final version, and we have a report on the roundtable discussions that will be hosted online on the project website, hopefully by the end of the summer. So with that, I will take any questions.
Thank you, Kendra. You're hired. What is spokesperson for open water data, for Internet of Water, for for Boise State, Idaho? Thank you so much. It's incredible work that you and your colleagues have all done. We actually had someone who mentioned Cynthia, and I'm not sure how to pronounce her last name, Valle or Valle. She noticed that there is a data gap in north central Idaho, and she said she can provide some gauge station locations and was asking how she could share the data with you. So I think we answered that, but we could also put that link perhaps, Kendra, in chat for people to more easily access.
Yeah, I can pull it up right now.
Great. So another question actually from Cynthia. She said she has worked for over a decade as a public lands hydrogeologist, emphasizing the importance of maintaining our gauge monitoring network. She said in both National Park Service and U.S. Forest Service, there is very limited, no internal support for data processing, and wanted to ask you if there are specific partners you can recommend to public lands resource managers for receiving data, processing, analytical support, et cetera, everything you mentioned.
Yeah, for sure. One thing that's really exciting is that I am currently working on a proposal that will be submitted to the Northwest CASC again this summer, and a primary partner on that project is the U.S. Forest Service. And so we have a handful of colleagues both in Idaho and in Montana that are interested in figuring out how to streamline water data management for the Forest Service. And I would imagine that could be extended to the National Park Service as well. And so I think one thing that you could do as far as support is the metadata template that's associated with this effort is linked in the additional content for the manuscript. And so one thing would be to just initially just make sure that your metadata is complete as possible. For data processing and analytical support, that is a huge gap right now. And so I don't have a solution yet, but I think that this is the community that will be really pushing, creating and developing those kind of things. And I would also be happy to chat with you as well in the future.
Excellent. And another thing, maybe, Paula, I know you're out there, if you could put Kendra's email also in chat so people can access that more easily as well. So that we'll be adding that to chat. So we welcome other questions. If you could post them in the Q&A. I do have a couple for you, Kendra. One of the things that one of the biggest challenges you mentioned was about getting data from the organizations. So this is kind of a two-part question for you. My question, do they have the data and they aren't keen to share it? Or is it that they don't have the data? And what would you say the percentages are for each of those?
Yeah, so
percentages.
Yeah, in the survey that we sent out to folks, it was, hold on, I'm just gonna drop this link in. I'll drop this link to the survey in here, and then you guys can post it back out to folks. So in the survey that we sent out to folks, there was actually a pretty small percentage that wasn't initially interested in sharing their data. I can't think off the top of my head, but I think it was like less than 30% were like, no, I'm not interested. And more commonly, folks were like, I'm unsure. And then the nice thing about the Streamflow data catalog is that we were asking for metadata instead of the data itself. And so that actually, in my mind, I think that is one mechanism to bring people in without having to actually get their data yet. And so it says, we just want to know where the data is and how much is out there so we can really highlight and leverage the fact that there is so much out there. And so that enabled people to come in a little bit more without having to already hand their data over. And when folks realized that, they were certainly more interested in contributing. But the biggest limiting factor for them on sharing their metadata was just staff time and resources. And so if they didn't already have a structure in place that centralized all of their metadata, then it was often like, hey, I need to spend some time doing this. And so maybe, a month would go by and then I'd send them an email and be like, hey, how's it going? Do you need any help? Can we support you doing this? And so oftentimes it was just them getting their backend data up to speed with some of the ways that we would currently consider to be like modern data management.
Right. I mean, I think that's, those are some really important findings, and something that, the data community at large, can really start to think about and maybe work together to resolve some of those challenges. I was curious, as a part 2 of that question, for those organizations that do have data and don't want to share it, how do you propose expanding data collection or making the case for those organizations to share their data?
That's a great question. I think being able to show folks how much data other people are willing to contribute. So let's say, for example, somebody goes into their watershed and they say, by having all of this data available, or like I can see 10 different organizations that are contributing to this data, and this data was really valuable for me or my organization's efforts. And so maybe that might compel folks to also contribute theirs. And I think having some examples of how other people's data would help them achieve their objectives would be a really good example, because then they're not just giving something up, they're also getting something out of it.
Great thoughts. That's one of these are kind of the questions that have come up in my mind as working with stakeholders and, trying to entice them in any which way. And so I think the more ways we can entice them, the better, the more data we will have and be able to share. We have a comment question from Martin Sewell. He says, nice work. Would there be interest to work with Quasi, as we have some options for sharing data and are working on a solution to help organizations with their data management?
Certainly. Yeah. I mean, Quasi has been a real thought leader in this space for a long time. And it's been great engaging with them on a variety of projects. I think one of our biggest challenges initially was that the way in order to get some data into Quasi, like there's kind of 2 modes of getting data into Quasi is the way I see it. There's like the easy mode where you just put it up there, or there's the harder mode where you have like very detailed metadata requirements that's highly structured. And the latter is really challenging for folks of these smaller organizations. And the former makes it actually, like I scrolled through and tried to pull data from Quasi, and it seems, and I could be wrong, but that Quasi is really engaging the academic community, but smaller organizations like watershed councils, for example, they're really great. There's a lot of them in Oregon that collect a lot of really great data, but they aren't as tapped in. And so I think one of the big things there is just figuring out how to get those small organizations to be linked in to things like Quasi and Internet of Water so that they can get some of that more up-to-date information. And I think for them, a really big thing is going to be having a requirement that's aligned with their funding sources that's associated with their data collection.
And there is something called the Water Data Collaborative that I think caters to small watershed organizations such as those that you're referring to, for example, in Oregon and I mean, across the country, really.
And I think, things like the Water Data Collaborative, they also focus a lot on water quality data. And so then there's also this big discrepancy between what does it mean to have good metadata for water quality versus Streamflow data. And some organizations collect both, but then some organizations only collect one or the other. So I think it's a community conversation that needs to just keep chipping away at any little way that we can pop into it.
So Taylor Christian out of Texas doesn't have a question, but she just had a comment that she wanted to share that from Texas perspective, collecting metadata from entities and the time spent on doing that is so much longer than they anticipated in the project.
Yeah, I completely agree. The number of emails is a lot, very time consuming on that. And also, again, like huge thanks to my students that did a lot of that legwork.
So I think I just had a kind of one last question for you, at least I do, and anyone else, please again feel free to put any questions or comments you might have in the Q&A. You came up with a long list of challenges, and I know that you've been working on some of the solutions. So if just a question about those solutions, if you were to implement one solution to the challenges you identified and listed in this project, what would it be?
I think the number one that I would love to see out there is a standardized metadata template that is open access and easily available to all organizations. And so effectively, if they collect Streamflow data, this is the template, this is how you fill it out, and it's completely standardized. So that way, next time Texas or another state wants to go out there and collect this information, organizations already have a really easy way to compile that information. And that's at least the first step to the bigger issue of data harmonization.
Well, I think this is an issue, a challenge that is kind of all hands on deck. And, I know this community is strong and active. And I think together, with solutions like that, for example, and what Internet of Water is doing with GeoConnects, and there's so many other organizations working on this that we will we will persevere. So really appreciate your efforts, Kendra. Thank you so much for this presentation. I wanted just to mention quickly.